When folks think about asteroids, they might think about dead chunks of rock that are floating around space. And what we see with Ceres is that processes are modifying the surface even in the present day.
Approaching Ceres, we saw this very bright region on the surface. And then as we got closer and closer, you saw that there were multiple bright regions in this one crater. There's the one in the center, which is called Cerealia Facula. And then there's the ones off to the side in the crater floor, which are called Venalia Faculae. Cerealia is located in a pit within the center of the crater. That pit is about 10 kilometers wide, and so it's about 1/9 the diameter of Octocrater itself. And then within that pit, there is a little central dome.
What we're seeing is an indication that there are liquid brines, potentially in the subsurface even in the present day, rising to the surface and becoming these bright spots. And that tells us that there has to be a process providing energy to drive these fluids to the surface. We call them bright spots, but actually it's a relative term. The brightest bright spot on Ceres, Cerealia Facula, has an albedo of around 0.5, which is about the same brightness as dirty snow. Bright spots on Ceres aren't limited to a single place. We found that there are over 300 bright spots all over the surface of Ceres, and that indicates that this is a relatively widespread process.
The salts that we see in Octocrater are a similar composition to salts that we find in Mono Lake in California. It's interesting that you can have these similar materials found in different places that were formed by different processes.
Ceres represents something of a bridge between the bodies of the inner solar system and the outer solar system. In the inner solar system, we see rocky bodies. In the outer solar system, we more broadly see icy bodies. And Ceres is sitting somewhere in between. We know now from the bright spots that it is changing. The bright spots that are already on the surface are darkening over timescales of hundreds of millions of years or even less. And we also see that the bright spots maybe are still forming. So Ceres is still an active body, and we still have a lot of questions about what are the processes that are modifying Ceres' surface over time, and what that tells us about the internal nature of Ceres and how it actually formed.